Welcome to the deep dive. Today, we're looking into some really interesting source material. It points towards this surprising link between concepts you might be hitting in calculus class and, well, something pretty down to earth, making fruit wine.
That's right. It's fascinating, actually. Our sources connect these mathematical ideas, specifically differentiation and integration, with the very practical agro-based process of producing wine from fruit.
Okay, so let's dive in. The goal for us here in this deep dive is really to unpack how these, core calculus concepts, thinking about rates of change, how things add up over time,
Yeah.
how they're actually used in a real place, like a winery, seeing the math off the page.
Exactly. And what the source material really highlights is how crucial it is to monitor fermentation. Because fermentation, well, it's fundamentally a process of change, isn't it? You have yeast converting sugar into alcohol, CO2.
And the speed of that conversion, that's the important part, right? This sounds like where differentiation steps in. If you're tracking the sugar, maybe checking the Brix levels with the hydrometer over time,
Right.
you get this series of measurements.
You do. You get those data points. And the rate at which those sugar levels, those Brix levels, are decreasing, that rate of change,
That's the derivative.
that's the derivative.
Yeah.
If you plotted sugar concentration, let's call it S, against time, T, then ds dt, the derivative, at any single point in time, it tells the winemaker precisely how fast that sugar is being consumed right then and there.
Okay. So that instantaneous rate, DSDT, that gives the winemaker really critical info. Like, is it fermenting too fast, getting too hot, maybe stressing the yeast?
Exactly. Or is it going too slow? Maybe it's sluggish or even completely stuck. That could mean the yeast isn't happy. Maybe it needs more nutrients.
Right. So by watching this rate, this derivative, they can make smart decisions quickly. If the rate plunges, maybe cool things down. If it slows down unexpectedly.
You might need to add some yeast nutrient or perhaps gently warm things up a bit. It's a very direct application using the derivative to understand how a process is changing moment by moment.
Okay, so differentiation helps manage the speed, the immediate situation. What about the bigger picture then? Where does the other major calculus idea integration come into this?
Right. So that's where you shift your focus. Instead of looking at the rate right now, you look at the total result over a period. If you know that rate of sugar consumption, dsdt, throughout the entire fermentation, integration lets you calculate the total amount of sugar that got used up during that whole time.
And why does the winemaker need to know the total sugar consumed? What does that tell them?
Well, because that total sugar consumed is directly linked to the total alcohol produced.
Yeah.
There's a pretty predictable ratio for how yeast turns sugar into alcohol. So by integrating that rate of sugar loss over the whole fermentation,
They can figure out the final alcohol percentage of the wine.
they can estimate it. Yeah, it gives them a very good idea of the final alcohol by volume.
Wow. Okay, so differentiation is like the speedometer telling you how fast you're going now, guiding those immediate adjustments. While integration is like calculating the total distance traveled, figuring out the cumulative result, the final alcohol.
That's a good way to put it. They're two sides of the same coin, really. Both are about analyzing that fermentation process using the fundamental ideas of calculus, rate, and accumulation. And this comes straight from the source material we looked at, showing these concepts as practical tools in winemaking.
So for you listening, what this deep dive into the sources really shows is how these math concepts, derivative, integral, they're not just abstract stuff in a textbook, they're actual tools. People use them to control quality, predict outcomes in, real world situations like turning fruit juice into wine.
Yeah, it really makes you think, doesn't it? How many other processes are out there, things in manufacturing, maybe environmental science, even finance, that might be quietly relying on calculus to track rates or figure out totals? What other connections are just waiting to be spotted?